Oh, this box. Every time I work on this amp, I have to field the same dozen questions. Every time like clockwork. I swear to God, I do not and will not build an amplifier more than 8 transistors for sideband. They get very sensitive when you get past 8 transistors, and the circuit gets a little wimbly-bimbly, I guess would be the best way to put it. This box I built for my buddy Bill. Bill is a super, super nice guy. When I put this amp together, this is obviously a gray label X-Force, otherwise Carl built. Let me grab some stuff as I'm giving you guys the oral history of this thing. Bill contacts me, oh gosh, it's been a long time now ago. I know, that's real specific on the timeline. When I worked on this amp the first time around, I gotta get in here to my wires boxes. You're gonna have to let me in here. Come on. The very first time I worked on this amp, it was a rebuild job. And as I get it put together, I shoot the video and I made it very clear to Bill and everybody that was listening on the YouTube videos that this is going to work, but it's not going to work the way you guys think, right? Everybody thinks more is more. No, not really. You have more and then you have stable more, okay? This is inherently not a very stable amplifier. It's just the way it is, you guys. I've tried every version of this. I've tried voltage regulated bias, temperature controlled bias, temperature with voltage controlled bias. This is passive thermal bias. As the load resistors heat up, we have the diodes placed. That's what I love about this bias design, is that it is voltage flexible, because the heating of the diodes next to the load resistors allows the leaking of the load resistors to change, and it allows us to have a little bit smoother curve, a little bit smoother curve in the diode's response to the load of the circuit that I want to apply to be able to achieve the class of operation that I want to get to. A bunch of fancy words saying this amp will work on sideband as a 16 pill, but freaking don't expect to get 4,000 watts out of it all the time on sideband. It's not going to happen. Every single time I work on this box, I will field probably 10 phone calls where somebody goes, "Hey, I see you biased up a 16 pill. You do mine?" And my answer is no. I rebuilt this box and it's been back here 4 times. 4 times. And I told him when I built the damn thing, I'm not going to make you any guarantees. There is no warranty on this box. He's like, "That's fine. I won't try and run it." I'm like, "Okay." So I did some tricky shit with the bias on this, and I changed the diodes on this just to give him a little bit better chance of making sure this box is going to work. It's an X-Force, okay? The heatsink ends right here. So we've got maybe 10 inches worth of sink, another 10 inches worth of sink. The cabinet is the standard X-Force cabinet, but I went in here with a Dremel, and this is before I had fancy tools, and I cut all the ribbing out to increase the airflow. What we should have done to give it a better chance of success is to put it in a 32 or a 24 pill cabinet to get more sink underneath these transistors, and then spread it out a little bit so we don't have quite such the heat saturation going on. These transistors are working really freaking hard when you're in sideband operation. The transistor's operating at full potential. I don't know if you guys have ever noticed, When I operate a piece of equipment on AM, we get 1 amp reading, and then when we go to sideband, it usually doubles, if not a little bit more, the amount of current draw. Well, we're still producing the same amount of peak power, but then we notice that average number takes off and runs like corners. It's kind of like the bird variable knobs that D-Rail's putting on everything. Puts a lot more load into the circuit. Is it really making that much of a measurable difference in somebody's S meter? No, probably not. But Bill has had a lot of fun with this amp over the years. Like I said, it's broke a couple times. And I tease him about it when he calls. Hey man, my amp broke. Cool, send it over. We'll take a look at it. And I go through it, and it usually blows a pill or two, and we change the pill or two out, and we move on. We just move on. That's what we do. We just move on. We accept what we've got going on. And I like him, he likes me, and we both understand where we're at. The problem is, when I work on this box, everybody calls, man, I seen you buy a box for sideband. They never watch the whole video, where I sit there and I go, no, 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 we don't want to do this. What do you think of my burn? I got that from an airbag deployment. There's a YouTube video out on that if you guys haven't seen it already. No, I don't want to recreate this amp. I'm just not interested in it. We know that we can take an 8 transistor amplifier and make it do about I try to set it up so the box doesn't produce anything more than about 1900 watts. Now, if we were going to run the same transistors on AM, and we class seed the nut jobs, we can get them to do 23, 24, 25 out of the Toshibas pretty reliably. The best shootout box I ever built in my life for the 8-pill class, and this is no joke, made almost 3100 bird and double that in peak power. So there's a lot of manipulation of the circuit that we can do. A 16-pill this small of enclosure with this kind of cooling system, I've told Bill 100 times, and he's heard me. I know he's heard me, and he's diligent to a T with what he does with his system. And usually, the last couple times it's broken, it's been something outside of the amp that's given him fits. Either be a coax connector or an antenna. He's got a very complex mobile. So it's back here again. 4th time around, and I will keep fixing this. I am not complaining. Like I said, this is my friend. This dude is my friend. I will keep fixing this amp until we have no more parts to put in it, which is a long ways from now. I mean, I got 600 new transistors and probably 400 used. We've got lots of time. And I don't mind this being a sacrificial animal, because every single time this thing breaks, I learn some new little thing. I go over to the book, I turn to Bill's page, I write down more notes, and I change the notes to say, okay, I changed this, and let's see how well it works. This last time around, it made it almost a year before there was a problem. I don't know if he just got long-winded on the key. I don't know. I don't remember when he called me and said it broke. I'm like, yeah, I don't care. Send it up. This is one of the few. There's probably like 4 amps that are in existence. That when the guy calls, I'm like, yeah, send it up. I want to see how you broke it this time, because I am honestly interested. I want to see how it failed, and this is that. And no, I will not build one for you, because 99% of the people in this hobby, if you build them an amp and it doesn't work perfectly, like perfect, they're all over Facebook and everywhere else that anybody might actually pay them attention and say, man, he did me wrong, that amp, I had him do this and that to it, and I used it for 2 keys and then the smoke come out. Where Bill and I, we understand each other, right? Okay, Bill, I'm gonna try some shit. We'll see if we can make this work. Like, if you notice, this is started out life probably as an 8-pill, and then somebody came along, Carl or whoever came along, and added another 8 transistors to it, right? So if we look, the transformer windings are different, the color, the Teflon is, the combiners are different. Over here, different color Teflon. I think this was an 8-pill, and it was a 10-pill, and then I turned it into a 16 or something. I don't know. The story's long and convoluted with this amp. It's been around. I will tell you right now, I'm going to repeat this one more time, and maybe everybody out there in YouTuber land will hear me say this. I won't do this for you. I mean, My buddy Spaceman or a couple other guys that I know that I'm really good friends with, and I know how to talk with them and they know how to talk with me, and I trust them, right? And they've had years and years and years worth of success off of equipment that I built for them. If they came to me and decided to say to me, well, we want to become the world's greatest sidebander, I'd be like, great. Absolutely great. We're going to take two 16-pin cabinets, we're going to bolt them puppies together. On one side, we're going to put 8 transistors. On the other side, we're going to put another 8 transistors. We're going to have 2 independent amps with combiners on the inside. So the electrical circuits are... The impedance and part of the process of achieving the sideband bias mode gets driven too low when we get at this chain of transistors. And if we'd split it up, we could probably make it work a little bit better for them. It'd also get more heat sink and more airflow and yada, yada, yada. You guys get it, right? There's a way to make this happen. But I would only do it for somebody that I know how to communicate with and understands that, hey, you stay on that key too long and the box gets too hot, you're going to pop a pill. Oh, and the other thing is half the parts in here were used. Transistors, right? So what kills transistors? They get too hot. You can't dissipate the heat. The transistor starts to heat up. It starts to lose its internal insulation because the inside of the transistor gets over, 80 degrees Celsius, right? Your HFE gain, which is a direct representation of the transistor's ability to isolate itself from base emitter, collector, collector, emitter, base, starts to break down, and eventually the transistor goes open. It goes into a state what they call tunneling, where it burrows through the insulation because the insulation is so corroded due to heat that electrons can flow either from emitter to collector, collector to emitter, or base. Got it? And then poof, we blow a pill. Most guys, unlike Bill, don't have watt meters in their stuff and aren't watt monger watchers, right? Bill's a needle watcher. He watches his needle like a 16-year-old looks at porn, right? The thing just doesn't twitch right. And he's like, nope, I'm sending it back to BBI. Just saying. So please, if you're watching this video, understand this is a one-of-a-kind, one-off prototype that's been here 4 times since it was initially built, and it's been running for like 7 years on and off, this box. I don't want to continue this experiment with you, whoever you are. I don't. This is a one-time, and I've said this from the very beginning. I'm not trying to be discriminatory in any way. This is my test kitchen, per se, for this setup. If I was to go through and redo this again today, there'd be a whole lot of different caps that I'd put in here, and like I said, we'd put it in a much larger cabinet. I would have never agreed to build it in this cabinet, but I wanted to try it. He was willing to experiment with me, and here we are. So we're going to use our arrow indicator to tell us where the problem's at. Visual diagnosis will tell us off of the overly sized, very generous smoke generating machines. I mean, the 5-watt resistors. We can put 2 watters in here. Actually, you can get away with using like 1/4 watt or even a 1/10 of a watt resistor across this circuit until there's a problem. And once there's the smallest amount of imbalance, it shows up in these resistors as heat. So if we have a burnt resistor here and a burnt resistor here, it tells us that the problem is in, we follow the coax, it tells us the problem is here. Now, we've also got this as kind of a visual aid too, saying, hey, yo, look at me. When you blow, either it be a 5-watt, a 2-watt, a 1/4 watt, your granny's pubes apart like this, at this violent of a level, that tells me that one of these transistors in here, come on brain, Luke, work with me here, man, I'm talking to myself. One of these transistors, when it went open underneath load, it went open while underneath full saturation, so sideband, basically. So hopefully one of these transistors didn't leak around and smoke the other part. Sometimes with all bipolar transistors, what can happen is our emitter can go open and the transistor loses its reference to ground, so your base and your collector short together. And it allows 12 volts to flow from this side of the circuit through the transistor, through the input transformer, and back into its partner transistor, and it wipes out 2 pills at the same time. Happens from time to time. And it doesn't specifically limit that. That's not limited to just this amplifier. We're talking overall. I've seen it happen hundreds of times, if not more than that. Please note, we're watching a YouTube channel where there's literally 4,000 videos or 3,000 something videos or whatever. I quit counting thousands ago. I think publicly YouTube's only willing to host for me because my channel base is a certain size, blah, blah, blah. I think it's like 1,500 videos or something. But in the back end, if you have access to the frickin' the YouTube video address, there's like 3,000 plus videos alone, just repairs. We're not talking new builds, but just repairs on the YouTube channel. We have seen this before, this violence in action. I guarantee you he heard this because it popped up and hit the tin, and then he smelled this. People can say whatever the frick they want. I don't give a shit. They can say whatever they want about the 5-watt resistor. I like them. I use them. There's a lot of people that use them. And if you're not using them, that's because you're being cheap. So you can come up with whatever convoluted BS garbage you want to say. At the end of the day, if the circuit's in balance, here, 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 and here, not through here, you can get away with using a 2-watt. I mean, you can get away with using 2 watts here, but how many flyback or harmonic suppressors have we seen burned up on this YouTube channel? Hundreds. Hundreds and hundreds and hundreds of them. Of those little burned up yellow 2-watt resistors. Hundreds of them we've seen go up in smoke. In the harmonic portion of the balance of the circuit, right? These resistors here. So, the great guru amp builder, whoever wants to ordain themselves that, because I don't give a shit who that is, and it's definitely not fucking me. The great guru amp builder that wants to sit in his little castle of self-righteousness and make YouTube videos where he's hating on people that use 5-watters, I go, up your butt. I don't care. I don't care. It works better with 5 watts. And the only reason you're carrying on about it is because you don't want to spend the money to put 5 watts in your box. It just works better. It does. This is living proof. Now the harmonic suppressors are smoked. These things, when they go up and they decide to, well, let out the internal resonance smoke, generate more smoke than the 2-watt resistors. And most people, how they know they have a problem is because they can smell their amp burning up because they don't run watt meters like Mr. Bill. I bet Mr. Bill was talking, and all of a sudden he unkeyed and went to key back up and his watts had dropped off. And he's like, nope, I'm done. Otherwise, these would have been completely fricasseed. You guys understand that we have 5 watts worth of dissipation and 5 watts worth of dissipation. It's only 3 more watts than what the normal, I mean, a very small handful of people are still using. It's a very small amount of energy difference. I'm talking 3 watts worth of dissipation and heat before we have failure in the resistor. When one of these things unloads, any one of these 2 pills, because that's a 2 pill, that's a 2 pill, that's a 2 pill, that's a 2 pill. When a fault happens in that circuit, there is, we're talking fully saturated, 1,000 watts, 1,000 watts, 1,000 watts, 1,000 watts. When one side of this quits, now we have a 250 watt or 500 watt imbalance that takes place inside the amplifier. We would have to have 500 watt glow bars in here on this circuit, and they wouldn't even work because they'd be wire wound, and then it'd throw the whole thing out of resonance, and we'd have all this inductor length and stuff. It wouldn't work, but we'd have to have a 500 watt resistor going from here to here or from here to here to mask the problem that's presented here, that this 4-pill section has become unbalanced. For us to be able to hide that with a resistor, we'd have to use a much larger resistor, like much, much larger. How much larger would we have to go? Well, these are 250 watt ohmites. So double this. These are 10K a piece. This is some guy's idea of a bleeder circuit that I just grabbed it because, well, they're 10K and 10K. But these are 250 watts each, so I'd have to have 2 of these end to end, and then 2 more end to end, and then 2 more end to end, and 2 more end to end, to make it so that the resistor wouldn't have any physical damage to it. So when I hear people say to me, oh, he's trying to hide imbalance in the amplifier, I say, bullshit. You cannot hide the imbalance. The 3 watts that these resistors can dissipate over the 2 watts, I like using them here because they generate so much more smoke, honestly. And it gives you a couple more keys to figure out you have a problem. It builds just a little bit more safety barrier. Now, if you're fully saturating the sections, these are going to disappear and atomize into black goody nastiness, right? They just disappear into smoke. Most people, they key the amplifier with a low carrier, and then they look for the carrier level, right? Then they try to modulate it up, usually once or twice. So these things only have to survive for like 2 or 3 keys before somebody really realizes they have a problem. This situation, I tell you, he was talking, and I bet you heard it went bloop, and he keyed the box a couple more times, went, nope, I have a problem. I stopped and just disconnected it and pulled it out of circuit. Let's get out our flashlight. Let's look down here in this very crowded space, down through here, and let's start counting out how many burnt up 10 ohm resistors we got. So we built into this when we originally put it together the most redundancy that we could. Talk to me, goose. Yep, right there. Pop transistor right there. So I'll have to pull this one and this one, the front two. We have to pull the one that's blown because we know it's blown. And then we have to pull its partner to get an HFE gain on it. If the HFE gain is below 5, we need to replace the transistor, by the way. It's exactly what I thought would happen. This would be our supposedly good transistor. It has got diode short, as you can see. This is the culprit that died, and this died while in operation. I can tell. Have I finally worn out? Look at that, I have. Hold on one second. Let's go over here. Let's grab our little needle nose. And now I'm going to get, as soon as I get off camera here, I'm going to order a new tester. Because when I finally bend the test tips, I found that I can bend them taut and make them bite one more time, and then after that, just get a new tester. These things are so cheap. No component detected. No. Both these transistors are shot. This one went open and failed because this one popped open. So let's talk about that. I mentioned it in the previous segment, but I probably put most of you to sleep and you guys fast forwarded through it. When this transistor went open here, and the lead that goes here and the lead that goes here will short internally. The emitter on the legs that hit the ground will pull away, just in the way the violence of the transistor going open, the traces, the little filaments that are on the inside will pull away from the transistor, okay? And then in turn, the 12 volt current from base to collector will fly through the transistor. It'll pass through the input transformer and then go back, dink, and wipe this part out. Now while we're here, I got to check our diode in our bias circuit because that can be affected too, taking into account we put 12 volts on both sides. So we'll take a look at that. But there's a reason why one transistor showing up as a diode and the other one showing up as no component. No component. This is the one that got wiped out by these two tabs having positive 12 volts applied to them. And this one is what failed, and it let the 12 volt current go from here to here. I can almost bet you money. I can almost bet you money. Here it is. So we got diode junction failure here. So we flip this around. It won't show it to us. Okay. Then we come over here. We apply our 12 volts here. We got nothing. Flip the leads around. We should also have nothing, and we don't. That one let the smoke go through. Food for thought, food for thought, food for thought. All right, so let me go find a couple high gain match transistors to put in this thing. And We'll wipe out the pill pockets. We'll get in here and make sure they're clean and spotless. We'll put some white man juice on the bottom of the transistors. We'll slide them down in there, and yeah. I'll flood this area with rubbing alcohol real quick and clean this up. 2 transistors in, and out the door she goes. Oh, look at that. That's a used transistor that's in there. I think that's what I replaced the last time it was here. I remember I had to work up here for some reason. I think I replaced this one and this one. Yeah, and these are originally stock. Which is odd, because if you think of the way the heat loading works on the amplifier, our cool air is going, blowing in, coming, turning. These transistors here in the front on both sides are what actually get the most amount of cooling, because by the time the air is moved to the back portion of the heat sink, it's already uptaked energy, heat energy, from the front portion, and usually it's the other way around. The back end is what takes the punishment. It just gets beat to death. That's why a skinny, long amplifier never works, because when you put the air in and push it all the way down the heatsink, if you get a foot or two down the heatsink, man, you get 6-10 inches down that heatsink, and you've already got your maximum amount of energy transfer going on to the air, right? The air is so hot that it's not going to pick up any more energy as it's passing through the heatsink. So we have to start compensating with volume of air. But okay, let's get going. Well, it's 2:30 in the morning. I've started no less than 6 projects today alone. That's 6 separate YouTube videos I've started and had to stop for a myriad of different reasons. Let's fire the FLIR back up. I'll show you what we got going on here. So we can see we still got heating in this resistor, because we've done the little repair. This is all put back together. I checked the diode, all that crap. Got heating over here. So there's still an imbalance in this 4-pill. This flyback's getting hot. This one's ice cold. So it tells me that this transistor has still got a problem with it. We just got done working on these 2. But we have a problem here in this transistor again. And I got to pull this matched partner out. It's like if I go to run this, at 0 and 2, these 2 transistors are trying. These are dead. Dead. Not doing shit. So I don't know what happened. I don't know what happened. Whatever it was, that section failed violently and with some huge issues. So we determined what happened here. Let's pull this apart over here and find out what happened there. And like a true sideband operator, homeboy's got to use a PTT on this. The auto key on this is not working. So he didn't mention anything to me about that, because he's got it hardwired into his radio. But we'll repair that too while we're in here. So I'll get my foot pedal out of the way. We'll unplug it, we'll flip it around. Unplugged. Ooh, God, I love welding lock leads. This is the only way to go right here. Let's flip it around. Let's do our boom diggity. Good morning, good evening, good afternoon. I think we found a problem. And as I was taking it apart, the lid came off. This is the one I replaced last time. Was this transistor. If I remember correctly, the gain was somewhere in the neighborhood of the high 70s. And I put a gain of 71 transistor in there, so let's see where we're at now today. Gain 53. Okay, let's go find you a matched beta gain transistor, and let's throw another transistor in this, and let's get this put back together. Called and talked with my friend Bill, the guy that owns this box, today. We're going to fix his other amplifier that's here. We're going to do it in this video too. Oh. Easy peasy. This box ran for it ran for a while. This time around it ran for like 4.5 months, and then maybe, come to find out, a little bit of operator error, whatever. Like I told him, I said, I don't care. I'll fix this thing 300 times. I don't give a shit. As an amp builder, that's one thing you can't get upset about. I don't care. You build somebody the Mona Lisa of an amplifier. The instant that the thing leaves your shop, you can't have any more emotional attachment to it. Like nothing. You can't even, nothing. Oh, you blew it up. Oh, that sucks. Let's fix it. That's your only attitude you get to have. And if you're not able to do that, you should probably think about doing something else, right? Like if you're an amp builder, when you call him, he gives you shit, like a hard time, like, man, you fucking rub on shit, blah, 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 blah. It's not the way that works. We're going to throw this in the bucket or the bag. Let's go find a transistor and let's get this amplifier working. Well, I think I got this fixed. I'm pretty sure. Let's give it a test. So we popped another transistor in there, cleaned the pill pockets out. It took a second, got out the drill bit, chamfered all the pill holes, make sure the pocket, you know, or the hardware goes into the heat sink, pulls the transistor down to the heat sink. Cleaned all that up, put it all back together, soldered up some bits and more pieces and parts. Back in one piece. So we're going to use the derail striker, 955. At 11111. 1000 watt scale. Oh, no, wait a minute. I had this turned down because I was teaching my friend some shit about his radio that he's got. Hello, 1212, 1212. Okay, so we're gonna put about 120 watts into this thing, ish. Let's see. Yesterday it was barely getting over 600. Let's key the amp. Hello. Yeah. Yeah, it's fixed. Hello. Yep. There's $2,000. No problem. Hello. Audio. So 125 watts going in, makes 2,500 watts of power out. It's amazing how quick the gain scale, the input power to drive scale. So like, let's say you put 125 watts in, we get 2,000 watts out. But then to reach fully saturation of the component, we have to go, you know, up to like 800, 900 peak watts worth of drive to fully saturate the part. So I'll show you what I mean. We're going to put just a hair more drive into it. Now we'll take the bench Striker 490 and we'll slap that son of a bitch in here, which does about 200 watts. So we're going to add, hit 1, 2. Whoa. Whoa, you guys, that's creepy. Wow, that was scary. I think I might have to invest some time in the shelf. The shelf that everybody's made a comment about how it might fall down. It just shifted. Ooh, that was scary. A lot of money up there on that shelf. Okay, and a lot of money down here on the workbench. Let's hit this with a 490, 200 more with about 50 more watts. With 2,200 watts going out, this wouldn't surprise me at all if we get close to $3,000. Oh, yeah, close to $3,000. Now to get that last 1,000 watts out of the box, we drive it pretty hard. But then again, this thing is completely biased, so. But it's fixed. Let's see if we got any imbalance heat. We do not. That's ice cold. That's ice cold. That one's ice cold, and so is that one. Perfectly cold. We're done. This thing's back to working. Okay. So I cannot wait to look at the problem child amplifier. Let me get this disconnected. Let me get the lid put on it. And yeah. We'll get the problem child out and we'll get it on the workbench. It take a couple minutes. And I'm going to make it so the shelf doesn't dump all the radio equipment on me. This is supposed to be a temporary shelf 10 years ago. I'm not going to tear this all apart because I don't want to spend that much time on it. But yeah, give me a minute. I got to work on this. That was a trip. I've never thought this thing was actually going to fall until just a second ago. So this is a tough one, you guys. This used to belong to somebody else that I used to do business with. He had the other ss-750 that you guys have all seen. This amp has been here before. I cannot recall. I honestly just can't recall. It was 5-ish years ago. Last time this was here, and then some things went down and I got a little bit upset with this guy, who by all accounts is a very nice person, but I just got frustrated with the situation and I ended up returning this thing. But I can't for the life of me returning it. I don't remember all that went down with this guy. Just, it's too much. There's too much stuff going on all the time. And it didn't have the band board in here. This was not present. The filter board. This has got a Wilkinson's broad spectrum combiner, broad spectrum combiner splitter circuit in it. These boards are made by Communications Concepts. I do remember, I think I had to change some transistors, and there was a problem, I think, with this pallet where the little Teflon spacer that sits down in here behind the end of the... Like, I vaguely remember this, and I remember I did a power wire upgrade and a plug upgrade on it, but none of this was in there. None of this was in there at all. Or was absent, or had been removed or something. I don't remember. This is my wiring here. This wire here, and these are my power wires up here to the shunt, and this is me. This is the way I would do things. Epoxy based heat shrink. This is me. My friend Bill bought this from this gentleman at a Hamfest, and this amp works. According to Bill, this amp works. What he wants to have happen is the filter board get put back in play. Please note what I just said. It's got a broad spectrum Wilkinson's lump sum combiner. Anything you put in this amplifier is going to rectify it. The inputs on all of these boards are completely attenuated. There's the pallet's set up for a broad spectrum of diversity. If I remember correctly, I had to add some capacitance to get this to work the way the gentleman that... This is not the stock remote, and they did sell this with a blank face on the front of it. I just bought one of these, a 750 and a 1200 version of these. It's got a separate face. This is the only one I've ever seen that doesn't have the switches on the front. There should be a band switch on the front that says like 80 or 120 and then 40 and then, you know, and so on all the way down to 10. This doesn't have that. So I do believe that this is a board from eBay. I couldn't name the builder of this board. I'm sure there's somebody out there in the comments. Somebody out there in the real world is going to leave a comment down the doobly-doo and be like, oh yeah, this board's built by so-and-so and so and so on. It's great. I don't hold any interest in this stuff. It just doesn't hold any interest to me. It's just a part that I can order to slam in here, and mentally took quick note of it. And I remember sending him an extra sticker. This is an ICA remote cabinet. This is one of my old logos, but I didn't build this remote. This is definitely big clunker divergence switchers like this are not my thing. This is more my speed. So our mission now, because this guy loves sideband and he wants to be able to do a full kilowatt from his mobile or close to it. Let's see if I remember correctly. These make like 500 or 600 watts on 80. Their maximum tune point, I think, is for 20 meters. You know, because the power curve works where it starts out low, and then as you go to the middle of the power curve or the middle of the resonant path for the amp, it'll peak, and then it'll drop off when we get up over towards 10 meters. So 160 or 80 or whatever down here. And then by the time we get over here, it'll be, there's a big bell, and in the middle is our maximum point of resonance with this amp, at least with these 4 pallets. And I'm so glad that each one of these amplifier pallets is working. I've got a couple of these control transistors. They look like an old metal body transistor, but they're a little bit more advanced than that. They've actually got 8 legs on them. So on the other ss-750 that was owned by the same guy, that amp was complete, and I had this transistor become unstable. So I just called up Communication Concepts. They sold me all the parts I needed, and done. So what we're going to do is we're going to take this apart first, because this kind of looks like this is a little bit of a kind of closet homebrew going on here. A couple of the screws that hold the filter board on were not in place, or they were just too long. I went ahead and I've added those. So we're going to pop these 4 screws off. I want to flip the board over. I want to see how the input and the output. This is obviously output side. This is obviously input side. So low watts, high watts. That is decent RG400. We're going to see if we can graft this into that and then actually make it work for all the different bands. That's our goal. Well, I guess we could start here. So I went ahead and I hooked up this filter board. So I found a reference to this on the eb401.ru low pass filter page. To me, this looks an awful lot like the FT10483.65 filter board. Whatever. Those are the part numbers. I found it on the Interboob. It comes from the European Apica-Color. I'm just gonna say that. It's all I'm gonna say. The remote that is inside this thing, or attached to this thing, I had to hotwire it. It had the positive wire broke off for the switch. I don't remember building this box. I don't. But there's certain parts in here that I'd put in here, like this is my on-off switch, right? And this is my LED and my LED holder. I don't remember putting the band selector knob. I didn't build this. Somebody else did, right? They didn't do too bad of a job, to be honest with you. There's quite a few things on this board we have to change. The band board is always hot, and all this does is interrupt the ability for the amp to key up or not. The primary on-off switch is this big connector here. This big breaker is what it is. This is all working. So to put the amp in transmit, we do this. I don't know what this was all about. This looks like the back piece of like your 6 or a 12-pin DIN connector. It's been shoved through with some hot heat shrink on it. I don't know. I don't know. I guess what we should do now is I got to fix some stuff on this. There's some solder work on here that's really quite poor. Let me disconnect this controller here. We'll get this out of the way for now. And we'll disconnect this from the amplifier. So this here is nothing I would do, and it is broken. There's 2 or 3 of these connectors that come off of this band selector that are broken. It's very weird to me. This board, we don't use this front half, right? So this would be like for an input attenuator and an input filter, okay? The output side is what we're interested in. And let me grab some zip tie cutters. Let's get in here and take a look at this. So let's disconnect this BNC here. Here's our output. Here's our input, and our input's got bare wire that's just kind of floating around on it. So we need to come in and repair this. On the bottom side, I can't help but notice that there's been some arcing here. You can see the burn mark here. And some of this wire that goes through, like this one here specifically, is not soldered. It's right here by my thumb. You can see the cold solder joint. So there's some stuff here that I want to repair before we go ahead and test it. But I want to plug it in. I want to see if this works. I'm very interested to see if this filter board works. I want to clean up the plug, even though this is working. I want to clean this up and really make sure the solder joints on here are good. As we can clearly see, we're split right down the middle. This is our input for the output band selector. And then this is the input for the, well, it'd be down here. This is the input for the input selector. The reason we don't need to worry about that is each one of these pallets have already got the attenuators built into it, right? And then we've got an attenuator over here attached on the heatsink that hides the input tune. That's basically what we're doing, is we're hiding things, right? So let me repair this here real quick and go over this real fast and get this cleaned up to where it's something that I would feel comfortable with the customer actually running. And let's go ahead and get this reinstalled and give it a whack and see what happens. See if we can get it even past any watts and kind of have an idea of what it's doing. I don't know. We will see. I have seen definitely far worse come through here for sure. I think that we'll be able to get this going here pretty quick for this gentleman though. Not gonna lie. So I got this all hooked up, and right now this is bolted to the back of the amp. A little cardboard box supporting it back here. Holding up, being held up by my Viper Venom Red Dot box. Yeah, let me show you the results that we have. So this is a 1,000 watt slug over here in PEP. Hold on a second. Realized I didn't have any time left on that memory card. Okay, so this is a 1,000 watt peak, 1,000 average 5 watt slug in reverse. So let's back out here. And I'm going to move you guys off to the side. So let's just key this real quick. Hello. Wow, that's really impressive, isn't it? I mean, that needle's really moving. So we have the band selector in 160. We're on 160 meters. So let's go ahead and let's bypass the band filter board, low pass filter, and make sure it's not our connectors. Hello, how'd it go? Oh, forgot to step on the pedal. Hello, 1 2 1 2 1 2. Okay, so things are moving now. I spent a few minutes looking at this now. Let's bring it back over here. Let's bring our FLIR into the equation. So the 10 meter position is on this side, as we can see. It's my finger. 10 meters hot. You can see the relays are hot. And the 160s are hot over here. So what we got going on is multiple bands on at the same time. I'm not too sure if that comes from the plug. When I probe inside the control unit, I have 12 volts on multiple pins, and it should be one on at a time. So this thing is trapping a bunch of RF in it. I mean, like a bunch, like 300, 400, 500 watts. It's not wanting to pass through. So I just meticulously put this whole thing together. Now I got to take it apart. I got to take the remote plug out. I've got to take this plug that's attached back here. I got to disconnect it, and I got to lay the whole thing out here, and let's see if we can get each one of the bands to individually fire, right? So I need to disconnect it from this thing, flip this whole mess around, and let's see what's going on, because I was kind of hoping this would be a turn on and work kind of thing. Now I see why. I'm just not going to finish that sentence. I understand what's going on now. That's where I'm going to go with that, and I'm going to be quiet now. Well, that wasn't easy to figure out, but we did it. Ended up mapping the whole plug system. I couldn't understand why it kept getting this thing switches on ground, by the way. It doesn't switch on hot. This stupid thing. It took me a minute. Really, it took me, let's see, what time is it now? Yeah, it took 2.5 hours. I started looking at the switch, and the 10 meter was always staying engaged. That's this gray wire up here in the corner. I'm going to take this all apart and redo it. I just wanted to get it working, this portion of it, because some of this stuff, flip-flopping it back and forth, the wires are so small, we're running against time without me having to, making it worse for myself, I guess would be the best way to put it. The little wafers that are in here, this little wafer bar, I would have the 10 meter and like the 15 meter were staying engaged all the time. And then I noticed that the switch was double-sided. Finally, after I mapped this whole flipping thing, looked at all the plugs, recognized things are actually switching the way they should, but the 10 meter and a 15 meter were staying engaged. Well, the 10 meter, there's another wafer on the inside of the front side of the switch, another whole armature that moves through. The finger stock was grabbing on both sides, and it was causing the 10 to stay completely engaged all the time. And then the finger stock was thick enough, or the finger stock from this side, there's slots. There's a slot right there, you see that? Where the finger stock could push through, and it was touching to this wafer. So all I had to do is bend the finger stock off the switch, and then I moved the wafer. Now I'm going to go in and I'll put some like capped on tape. I'll put it down in here, but I moved the wafer out of the way so the wafer isn't making contact and engaging all the other bands, right? So let's go over here to the ICOM. We'll start on 160 meters. So first I'll show you input power. Hello, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2. And this is on 12 volts, okay? So we'll come over here and we'll look at the spectrum analyzer and we'll see where we're actually putting out power. 1, 2, 1, 2, 1, 2. Now you guys are so insistent that hold on, let me do air quotes here. The technicians in the universe are so in the know that they insist that I have my oscilloscope set up here for 500 megahertz wide. See that stop? The stop point right. Where is it? Right there. 500 megahertz. So where we're looking is all the way down here, about the thickness of my finger, is the whole amount of spectrum we're going to work in. And the reason that they say that I got to show information like this and have the spectrum analyzer so wide is, well, what about the second, the third, the fourth, and the fifth harmonic? Right. They could get out to a couple hundred megahertz. I get it, but it doesn't work so hot when I'm trying to demonstrate something on YouTube video. So, just saying. Here's drive power. Hello, 1, 2, 1, 2. You see that slight change. Hello, 1, 2, 1, 2, 1, 2. Hello. You can almost see it down there, right? Here's the amplifier engaged. Hello, 1, 2, 1, 2. You guys see it? Okay, good. Now that we've had a valid form of measurement that we can't see with the naked eye because other technicians that know better than me. I mean, if it was me, I would have this entire thing set up so it was 56 megahertz wide. Or maybe 100 megahertz wide. Not all the way out to 500 megahertz, but I digress. Okay, let's go on up to 80. Here's 80. Now we might actually see some movement on the scale at 0, 1, 2, 1, 2, 1, 2. See this here? At 0, 1, 2, 1, 2. See that little tiny bit of envelope growth on the edge there? At 0, 1, 2, 1, 2, 1, 2. Okay. So what we're demonstrating is that we've got clean signal. That's it. And that the low pass filter is doing its job. All right, let's go on up to 20. Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Okay, now we'll go on over to 20. Let's see, it has 7, not 20. There we go. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Good to go. I'll get to 15 meters. We'll punch that up here. Hello, 1, 2, 1, 2. Hello, 1, 2, 1, 2. Okay, and then on to 10. And 10. Hello, 1, 2, 1, 2, 1, 2. Pardon me, hold on, 10, 28 megahertz, dummy. There you go. Hello, 1, 2. I remember I took a written test one time to demonstrate the actual knowledge of the bands. Hello, 1, 2, 1, 2. Oh. Hello, 1, 2. Hello. Hello, 1, 2, 1, 2. There we go. 1, 2, 1, 2. Turn the knob too far. So 99% of the measurement that we have to do with a spectrum analyzer, according to the experts in the world, at 0, 1, 2, 1, 2, I do within 1 finger's width of the end of the scale. Isn't that cute? That's so cute. But in reality, it doesn't work so hot like that. It really doesn't. So we'll say span. Let's see, stop. Change this to 100 megahertz. So now let's rework this with data that we can see. I get so tired of this. I wish I could set things up the way they make sense to me, but there's the so-called experts. They're tiny little peckers. Okay, 1, 2, 1, 2, 1, 2. So that's all the way down there at the end. Hello, 1, 2. Hello, 1, 2. Okay. Hello, 1, 2, 1, 2, 1, 2. Wow, impressive, right? Let's go to 80. Hello, 1, 2, 1, 2, 1, 2. See how much easier that is to see for the common guy? Hello, 1, 2, 1, 2. Just saying. Don't think I'm getting negative, because I'm not. Just getting tired of it. Hello, 1, 2, 1, 2, 1, 2. That's the amplifier. Hello, 1, 2, 1, 2. Here's just the icon. Hello, 1, 2, 1, 2, 1, 2. Okay. So I'll go to 14 megahertz. There we go. Hello, 1, 2, 1, 2, 1, 2. Boy, that sure looks clean to me. I hope all the internet keyboard Rambos that spend a bunch of money on education can agree with me. No. All right, so that was on 12 volts. So now let's kick our voltage up here to about 14.8. We'll go on back down here to 160. Radio 160. Yep. Okay. So, with volts on it now, at 012. Where are we at? Oh, we're too low. There we go. At 01212. Now we're making good power. So just the ICOM driving this thing at 01212, putting about 80 watts in it. Now remember, we're actually outside of the element's ability to read. Because remember, these are 2 through 30 megahertz elements. And we're just outside that window. At 01212. Making about 550 watts. Let's go to 80 meters. Now we're inside the element's ability to read. At 012. The radio is 100%. Am I on 2x or 1x? I'm on 2. Oh boy, this is going to get interesting. Now we're on 1x. At 01212. Yeah. At 012, 100 watts of drive. At 012, off the scale. So up to 2x. At 012, so we're making about 1200 watts worth of power. So this thing's operating just like an ss-1250 now. I want to go back down to 160 now that I understand I have my meters set up wrong. Okay, so we're on 14.5. Yep, 14.8. 160 at 012. Just over 1,000 watts. God dang, that's going to be great out of the mobile. At 01212. At 012. Boy, that's going to work great for this guy. Let's jump up here to 20, where he actually cares about working. At 012. At 012, right at about 1,000 watts. So, back down. At 0. It's clean power. Yep. Okay, 15. Now I want to go play with 10 off camera because something is not right there. At 012, same amount of watts. We're good. We're good. I'm gonna go twiddly fight around with 10 for a minute because something's not technically 1,000%, but all the lower bands, 160, 80, 40, yeah, 20 meters, all working like a top. 15, not so hot. 10, I think there's a problem on 10. So, I mean, all the pictures I see in this coil system wasn't this way, but it is definitely engaging. Let's go play with 10. I'll be back. You remember the burnt mark that I showed you a couple segments ago? Yeah, there's a reason that burn mark was there. Some burn traces apparently. And it was burned underneath this relay and this relay. So I just went ahead and created new traces because believe it or not, the trace material on this board is very, well, thin. It's just easier to put new traces to activate the relays. Hello, 1, 2. So we're seeing a good, nice, solid, clean 600 watts. Hello, with about 80 watts of drive. Hello, 1, 2, 1, 2, 1, 2. Make sure I'm not reading it wrong. I'm reading it right. Okay, it's in a 1K position. Hello, 1, 2, 1, 2. Man, does this thing get with it? Down on 80. My God. Hello, audio, 1, 2. This guy is going to be a god on 80 meters. The mobile. Everybody's going to be like, you're not mobile. Yeah, you are. Yeah. I mean, that's just... Whew. Hello, 1 2. Hello, 1 2 1 2 1 2. I mean, we're talking legal limit, or just a hair under legal limit from the mobile. This is kind of a hybrid abortion. I remember the last time this was here, and this was not on there. But there's no way this would have worked. There's no way this would have worked. There's a little piece of solder stuck underneath this coil. I sure hate to put this back together and then have that wiggle out and short everything out. It'll be bad. Okay, so now what I got to do is I got to put some elastic on this plug to make sure it lasts, because I got to think it's going to be in the mobile and that joint's just going to be fluttering in there. So I want to put some heat shrink on this to make sure it doesn't touch anything conductive. So I'll take and probably put a heat shrink sleeve with a zip tie on it that we can unclip and slide out of the way, you know what I mean? And then elastic this up, and we'll put the lid down on it, and then I want to rebuild the plug, because all of these little fine wires are just able to twist. You see that? It's just a matter of time. So I'd like to change that out and put a strain relief on it and clean up all the connections that are on the inside of that. So let's get this all buttoned up, and that put onto there, and this put into that, and then, you know, this and that, and we'll get her done. Give me just a second, and we'll be back to talk about the remote. Well, this now has a strain relief on the back, right? So I took the whole switch apart, and still the big donkey dick doesn't do anything. The switch turns everything on. Hello, 1 2 1 2. Hello, audio. Hello, audio. Pretty much spot on the money. This thing does about 800 watts on 80, on 12 volts. But when you push that voltage a little higher, hello, 1 2. Everything's laid in the corner. Well, gentlemen, on that note, I'm out of here. My buddy Bill, he can buy himself a VGA extension cable, and he'll be able to extend this up and put this someplace. Man, they really welded the hell out of that, didn't they? Anywho, that's it. I'll say thank you to my Patreons for letting us have this last little bit together without any kind of ads. If you like what I've done here on video and you want to show support, really the best way to do it for the channel is to come join me on Patreon and just hang out. Interact with everybody, comment, talk. Just come be on Patreon with us. It's BBI Amps on Patreon. Come find us. Big shout out to Siglent, Penta XS, Bird, MechMan, Coaxial Dynamics. Big thanks to all of you. On that note, I gotta run. Sit down in front of the computer, I'm gonna edit this up. And then I think I gotta look at a 2-pill LD MOS amplifier after this. And I think it might be for sale. Gentlemen, I'll see you. Click, click.